Welcome to lesson 7.2, and by the end of this lesson you'll be able to say that I can use the order of operations to simplify expressions. Now today's lesson just builds off of what we started to discuss in lesson 7.1, which was being able to use the order of operations to understand expressions and what is being asked in which order, as well as being able to write expressions with words or take the words and turn them into numbers and symbols. So today we're just going to practice going deeper into simplifying expressions the right way. Now this picture actually gives you a pretty good idea of how we simplify and look at expressions. Expressions, especially when they contain parentheses and things like that, will contain a problem within a problem, much like this picture is a picture within a picture. The first thing we do is remember that an expression is like an equation without an equal sign. So we simply have to, instead of finding the answer or the other side, we're going to simplify that down. Meaning this is like a difficult way to say something that we're going to say in a more simple way by the end by following PEMDAS. Remember, we have the order of operations. PEMDAS. And I wrote the M and the D and the A and the S side by side because we remember from yesterday that when we simplify or solve expressions, that we do multiplication and division before addition and subtraction, but we might divide before we multiply or add before we subtract, depending on which order they appear in the problem. So let's look at the expression we have over here on the left. In this expression, we first see 12 subtract 3 times 2. But we know that we wouldn't solve that in that order because our order of operations would tell us to first go to the multiplication section. So we have to think of this now as, instead of 12 minus 3 times 2, as 3 times 2 first. So I'm going to go to that part of the problem and I'm going to solve that part first. 3 times 2 is 6. Now I simply bring down what's left of the expression. 12 minus 6. And I have 12 minus 6, and that gives me 6. And so the final simplified version of this expression is simply 6. This expression was just a more difficult way of saying 6. Now if you notice, when we solve, we went down step by step and kind of formed an upside down triangle. And I want you to keep that in mind because we're going to keep doing that as we continue to solve expressions. So let's look at these two expressions here. The first one contains no parentheses, and the one on the right does contain a set of parentheses. All we have to do is apply our order of operations, and we can simplify these expressions. So we go across to the expression on the left, and we look through, and we see that our order of operations would tell us that I need to divide first before I add. So I look at 15 divided by 3, and I know that that is 5. I go back to the start of the problem and I read again from left to right, and just drop down what's left of the expression. I'm now left with 5 plus 5. And I can add that and I get 10. Here's my triangle. This expression simplified would be 10. Over here, I now have to look at a few steps. The first step I look at is what's in parentheses, and that tells me I have 3 plus 2, which is 5. Now I go back and rewrite the problem in order, bringing down what's left. So I still have 6 times, and that goes before the 5, and then I drop down the divide by 3. Now I go back and reapply the order of operations. So I have multiplication and division in the same problem. Order of operation tells me that I need to multiply before I divide, if that's what comes first in the expression. So this ends up being now 6 times 5 gives me 30, and then I drop down what's left of the expression, the divide by 3. And now I have 30 divided by 3, which results in 10. So this expression simplified also gives us 10. We can apply the order of operations even to problems that have decimals and fractions instead of just whole numbers. So let's look at how we would do that here. the order of operations still applies. So when I look at the first expression, I go to what's in parentheses first. I have 4/6 minus a third, and then multiply that by 5. So I begin with the parentheses, 4/6 minus a third. Well, I know that I'm going to have to change that to 2/6 because I have to have common denominators. So 4/6 minus 2/6 results in 2/6. I go back to the problem, see that I finished this part, and I drop down what's left. I have multiply by 5 left. So now I need to do that next step. I can go ahead and put that over 1 and multiply down, and I see that I have 10/6, which would be equal to 1 and 4/6. And then the expression on the left over here actually uses, on the right actually uses decimals. So I have to look at the order of operations. I see first I have addition, and then I have multiplication, and then another addition symbol. So I go to the multiplication part first, because that's what the order of operations tells me to do. So I center in on that, and I solve that part first. So I have 2/10 times 5. That would be 1 whole. 2/10 times 5, 1 whole. Now I go back up to the rest of the expression and bring down what's left from left to right until everything has dropped down a level. So now I bring down 3/10 and the addition symbol, and I bring down the rest of the problem, which is plus 4/10. And now I have to go and move again from left to right, looking for the order of operations. Since I have 2 addition symbols, that means there are 2 different addition problems to solve within this. So I start with the first one. The first one would be 3/10 plus 1. So that would be 1 and 3/10. And then I bring down what's left, plus 4/10. And now I can just finish the remaining section. 1 and 3/10 plus 4/10 would be 1 and 7/10. There's my triangle. There's no operations left, so that is the end of that expression. I have simplified it. So now I must ask you a question. Are you ready to try a few of these on your own? Let's start with this expression. Go ahead and pause the video and solve the expression step by step using your order of operations. Let's check your work. This expression simplified should result in 6 and 6/8. We'll go back and see how that worked. We started with the parentheses. 5/8 minus 1/4. When I go and make the common denominators, I end up with 5/8 minus 2/8, which gave us 3/8. I dropped that down. Then I went and brought down the rest of what the expression had. So I brought down the 6 plus and the multiply 2. When left with that, I now had to go to the next step of the order of operations and saw that I have to do the multiplication first because I reapply the order again. So 3/8 times 2 came first. That gave me 6/8. I brought that down, and then I brought down the 6 plus. And when I add 6 to 6/8, I end up with 6 and 6/8. Here's another one for you to try. Copy down this expression and then simplify it using your order of operations. When you're ready, you can push play and check your work. The answer here is 20, and we'll go back step by step. I look at my order of operations. All I have here are addition and subtraction symbols and no parentheses. That means that I have to apply the order of operations looking at addition and subtraction, whichever comes first in the problem. So in this situation, I have subtraction first. So I start with 18 minus 3. That gave me 15. I then dropped down the remainder of the expression. Then I went back to the beginning of the problem and looked for my order of operations. This time, addition came first. So I did 15 plus 9, or added to 9, and that gave me 24. And I dropped down the remainder of the expression. That left me with 24 subtract 4. 24 subtract 4 brought me to 20. There's my nice reverse triangle. I'm simplified down to one number, and the problem is done. Sometimes you might see two sets of parentheses. So we need to do each set of parentheses separately and then apply the expression that comes between them. And that would go like this. The first set of parentheses tells me I have 1 subtract 2/5. So that's 5/5 minus 2/5. That gives me 3/5. And I'm going to bring down the rest of the expression. When I see that, now I have a new set of parentheses, which would come before the other operation. So now I solve that section, and I know 1 subtract 3/8. Well, that's just 8/8 minus 3/8. So I have 5/8. And I go back, and I bring down what's left with the symbol, the operation. So that leaves me with 3/5 times 5/8. That I can cross cancel. 1 and 1. 5 goes into itself once, and 5 goes into itself once. And that leaves me with 3/8. Here's an expression similar to the one on the left that uses decimals instead of fractions, but we still have two sets of parentheses. So I want you to pause the video and try to simplify this expression, and then we'll come back and review. So I hope that you found that the simplified version would be 8. Let's talk about how we got there. We looked and saw two sets of parentheses, so we start with the set of parentheses that comes first. When I add these two, I get 4, and then drop down the rest of the expression. Now I do what's in the second set of parentheses. If I take 2 and 2/10, subtract 1 and 7/10, I end up with 5/10. I brought that down, and then I dropped the rest of the expression. And that left me with 4 divided by 5/10. So when I divide 4 by 5/10, I end up with 8. If you need a reminder of how that would happen, that is 4 divided by 5/10, not this. I'm sorry, not this. That would be 5/10 divided by 4, which is not what the problem shows. The problem shows 4 being divided by 5/10. So I move over the decimal 1. There's an imaginary decimal here that I move over. I bring up to the top, and I add a 0 here. So now basically what I have is 5 going into 40, and that goes in 8 times. The last thing I'm going to show you is another way to group things within an expression, which are known as brackets and braces. So the brackets look kind of like half rectangles here, and the braces look like swirly versions of those. And when you see an expression, sometimes you will see brackets and braces. What happens is that we are going to divide the problem up into smaller sections using those symbols. We do what's inside of the brackets or the braces before we go outside of them. So let's take an expression like this one. What you need to know about using brackets and braces is that they almost set the problem off into different sections. So I still am going to use my order of operations. I want to look for what's in parentheses first, but I'm going to look for what's in parentheses first based on what's inside the bracket or brace first. And if you thought about the way they go together, or if you'll see them, it will always have brackets on the outside, then braces inside that, and then the parentheses would be the next step inside there. And we actually work from the inside out. I do what's inside of the parentheses first, then I'll move on to what's left in the brackets. I'm sorry, in the brackets, and then finally move on to what would be left inside of the braces. And we'll look at problems that involve those, but we'll apply it right here. So of course when I see this expression, I see both brackets and parentheses. So I'm going to start with what's in parentheses first, just like I always have. That leaves me with 12 subtract 7 is 5. Now I want to drop down the rest of the expression, just like I have been. I'll keep what's in the brackets. I have 5, and now I have times 2 left. And then I bring down the rest of what's remaining outside of the brackets. And I'm going to do what's in the brackets, what's left in the brackets next. So that would be 5 divided by 2, which is 10. And now I bring down the rest of the expression. 100 divided by 10 would leave us with 10. Here's another problem that uses parentheses and brackets. We'll go back to our order of operations. I start always with what's inside of the brackets and the parentheses that are in there. Now I'll never have brackets without having parentheses, and I'll never have braces unless there are brackets. So parentheses always come first in a problem. 18 subtract 8 will bring me 10. I bring down the bracket and what was left inside the bracket, which is multiply 3. And then I bring down the remainder of what's in the expression. I have 60 now divided by what I get when I complete 10 multiplied by 3. So I do that section next. The brackets come first. That gives me 30. I bring down the rest of the expression. 60 subtract 30. I'm sorry, not 60 subtract 30, 60 divided by 30. And I would get 2. Now here's a problem that actually involves parentheses, brackets, and braces. Here you see your parentheses, here you see your brackets, and out here are the braces. So the way I look at this, or the way you'll look at this, is the first thing to do is go into what's in the braces. And then within the braces I look within the brackets for parentheses, and I start with what's in the parentheses. So I have 2 divided by 1 first. So that gives me 2. Now I'm going to bring down the rest of the expression, moving all the way around it. So I start by bringing down what's left in the bracket. I still have in that bracket 4 divided, and it ends up being by 2, because that's what's left in the bracket. And then I bring down the brace, and inside of the brace here we can still see I have an 8 divided, the operation symbol, and then I take down what was left outside of that. Now, since I have left just a bracket and a brace, I go into what's in the bracket. That's 4 divided by 2, which is 2. So I bring down the rest of what's in the brace, and that is 8 with a division symbol, the operation, and I have those braces left. And then I bring down again what's left outside of them. I'm still going to go with what's inside those braces first. So I have 8 divided by 2 is 4. I bring down what's left outside of them. I've gotten rid of those now. And all I have left is the simple expression of 10 subtract 4, and we get 6. Since using the brackets and braces and parentheses all together in an expression is a little bit more sophisticated, we'll try doing the practice problems for those together in class. I'm sure you're all just bubbling over with excitement and you feel somewhere over the rainbow to get started on doing these tomorrow in class. I look forward to working with you and can't wait to answer any questions you might have.